Hello all, welcome to C programming. In this video, we shall discuss about a program, C program, which performs addition operation on two matrices. So this is the program for the same. So before this, let us understand how the addition of matrices is performed with the help of an example. So for performing addition on any matrices, so the order of both the matrices should be same. For example, if one matrix is of order 2 cross 2, then the another matrix should also be of the order 2 cross 2 itself. So here in this example, we have taken two matrices or matrices whose order is 3 cross 3. So matrix A, matrix B. Matrix A and B. So matrix A's order is 3 cross 3, that is it has 3 rows and 3 columns. Matrix B also has 3 rows and 3 columns. So how matrix addition is performed? So now these are the elements present: 1 2 3 4 5 6 7 8 9. So 1 is present in first row, first column. Similarly 5 is present in second row, second column. If I take 60, it is present here at second row, third column. Okay. So when we add these two matrices, what will be the result? This is the result that we are getting. So if you keenly observe, we have a value called as 11 here. So how did we get 11? When we add this 1 and 10, 10 plus 1, 11 will come here. Next, 20 plus 2, 22 will come here. 3 plus 30, 33 will come here. Similarly, 80 plus 8, 88 will come here. 90 plus 9, 99 will come here. So this is how matrix addition is performed. Now the same thing we shall achieve with the help of C program. So in our C program, first we need to read the order of matrix. So whether it is 2 cross 2 or 3 cross 3 or 2 cross 3 or 3 cross 4, we need to read the order of the matrix. After that, we will be reading the elements of matrix A, elements of matrix B. Next, after that, we will be performing the addition operation, and finally we will be displaying the result. So I have already written the program. So first I shall execute this program and then check whether this program is right or not. If it is right, then what we shall do? We shall try to understand this program by tracing it. So first what I will do, I will execute the program with the same input which we had discussed as an example. So we had as an example took 3 cross 3. We had taken as an example two matrices of order 3 cross 3. So I will say enter the order 3 cross 3. Enter the elements of first matrix. So I will enter the elements of first matrix as 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, enter the elements of second matrix. So as we know, I'll enter 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. So this is the result which our program has produced. So after reading all the elements of first and second matrix, it has displayed the elements of the first matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Second matrix 10, 20, 30, 40, 50, 60, 70, 80, 90. Resultant matrix 11, 22, 33, 44, 55, 66, 77, 88, 99. So our program has produced a perfect output. So if you want to cross verify it, let us go back to that example. So look at the example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 80, 90. And here we have 11, 22, 33, 44, 55, 66, 77, 88, 99. So our program is working perfectly right. Now let us try to understand the program, how it works. Now see here, initially this is a declaration statement. This is a declaration statement. So because of this declaration statement, memory will be allocated to A, memory will be allocated to matrix B. So memory will be allocated to matrix or resultant matrix. Okay. So matrix can be stored in a two-dimensional array. So that is why we have used three variables which are of two-dimensional array. So matrix A, matrix B, and resultant matrix. Apart from that, we require normal variables R, R to store the number of rows, C to store the total number of columns. Next, I and J for iteration. I and J for iteration. Now let us see how it works. When initially first statement that will be executed is enter order of rows and columns for the matrix. So this statement will be executed. Enter rows and columns. So what I will do, just a minute. So when this statement gets executed, it will display enter the order of rows and columns for the matrix. So next I will enter 3 and 3. So when I enter 3 and 3, here in R, what will come and sit? R %D. That is the 3 which I am entering from the keyboard. So what will come and sit here in C? C also 3, because I enter 3. So this 3 will be read from the keyboard and stored in the variable C. So in both variable R and C, we have values 3 stored each. Okay. Next, we shall see how this part executes. Enter the elements of first matrix. So when I complete the execution of this part, so all these elements I will be reading from the keyboard and I will be storing it in where? In matrix A. Matrix A. So how it works? Okay. So let us see how this program works. Now enter the elements of final matrix. So first matrix. So this statement will be displayed here. Enter the elements of first matrix. After that, what happens? Here we have variable I and variable j. We have two for loops, external for loop, internal for loop. So we know how the for loop works. As long as this condition is true, the for loop will continuously loop. As long as this condition is true, the internal for loop will continuously loop. So now first we shall check with the external for loop. So what happens with the external for loop? Here I is equal to 0, variable I is equal to 0, I is less than R. What is stored in R? Value 3. So 0 is less than 3. Condition is true. I will get inside. Next, we have variable j. J is initialized to 0. So 0 is less than, what is value of C? C is also 3. Value of C is also 3. Now what happens? 0 is less than 3. So what happens? I will enter here. I will execute this scanf statement. So what this scanf statement will do? It will read an integer from the keyboard and it will store mat of A of ij. So mat A of ij. Mat A of ij. So what is the value of I here? 0. What is the value of j? 0. So in mat 0, 0, what will be stored? Whatever the number that I will be entering in the keyboard. So the first number that I am entering in the keyboard is 1. So this 1 will be read from the keyboard and where it will be stored? At mat of 0, 0. At mat of 0, 0. So that's why here we have 1. Here we have 1. Next, again it will iterate. Again it will iterate. But here what we need to understand is continuously, when the value of I is equal to 0, so j's value will move from j is equal to 0, j is equal to 1, j is equal to 2 and j is equal to 3. So this internal for loop will work successfully for j is equal to 0, for j is equal to 1 and j is equal to 2. But when j value becomes 3, it will not work, because 3 is not equal, less than 3, this condition will fail. It means for I is equal to 0, j value will move from 0. So first we have 0, 0. Next, otherwise I'll look at like this. So every time it will be 0, 0, 0, 1, 0, 2. So this is I, this is j. So I value will remain same, j value will move from 0, 1, 2. So first time when I read something in 0, 0, I will read 1. Next time when I want to read something in 0, 1, which I am supplying with the second number which I am supplying, so 2 will come here. Next number which I read and which I store at 0, 2, So I have read 3, so 3 will come and it will be stored here. Stored here. After this, what happens? When the value of j becomes 3, when the value of j becomes 3, this condition will fail. So when this condition fails, so what we'll do? So when this condition fails, directly I'll come to this point. So I'll go to the external for loop again. I'll increment the value of I. Now the value of I, this 0 will be replaced by 1 because I plus plus. Now what happens? 1 is less than 3. 1 is less than 3. Again the condition is true. Again I'll get inside. So when I get inside, again what happens? The same set of operations will be repeated. So when value of I is equal to 1, j will again move from, again it will be incremented from 0, 1, 2, 3. For 0 it will be what? This condition will be true. For 1 the condition will be true. For 2 the condition will be true. But when the value of j becomes 3, this condition will fail. It means what happens now? The value of I and j will move like this. Value of I will remain same. Value of j, first it will be 0, 1, 2. It means 1, 0, 1, 1, 1, 2. It means the next set of elements which we will be reading, that is 4. 4 will be stored at 1, 0. So 1, 0 is here. Next 5 which I will be reading from the keyboard, it will be stored at 1, 1. So 5 will come here. Next 1, 2 which I am reading from the 6 which I am reading, it will be stored at location 1, 2. So 1, 2 is here. So in this fashion what we did? We read the second row elements 4, 5, 6. 4, 5, 6. In the next iteration what happens? Now you should tell me what happens in the next iteration. In the next iteration, the value of I will become 2. So value of I will become 2. It will remain same. Value of j will move from 0, 1, 2. Now what happens? The next elements which I will be reading 7, 8, 9. So 7 will be stored at location 2, 0. 8 will be stored at location 2, 1. Next 9 will be stored at location 2, 2. 2, 2. So it means by this time what we have done? We have completed reading the elements of matrix, first matrix. Okay, first matrix. With the help of which statements? With the help of these statements. With the help of these statements, what we have done? We have completed reading these elements which we have read from the keyboard and we have stored it into memory. Similarly, with the help of these statements, what we will be able to do? Whatever the elements that we are supplying through the keyboard, so these elements will be read from the keyboard and where they will be stored? In matrix B. So as we traced for matrix A, similarly you trace it for matrix B, we'll understand that the numbers which we are reading from the keyboard, they will be stored into matrix B, okay, in the memory. So once we have read the matrix from the keyboard, matrix A and B, so next what we are supposed to do? Next we are supposed to perform what? Matrix addition. So to perform this addition, we have this code. So this code, what it does? It performs addition. So how it performs addition? Again the value of I and j will move like this. So first value of I will be 0. 0, 0, 0, 0. The value of I will be 0. But the value of j, it will be 0, next 1 and 2. Next value of I will become 1, 1, 1. Value of j will move from 0, 1, 2. Next value of I will be 2, 2, 2. Value of j will be 0, 1, 2. So because of these two for loops, the iteration will begin like this. So first it will be 0, 0, next 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. In this fashion, the value of I and j will increase. Okay? So now what happens? What this operation will do? Matrix ij. So initially we know what will be the first value of I and j? 0 and 0. So here 0, 0, 0, 0. What is matrix A of 0, 0? It is 1. 1. What is matrix B of 0, 0? It is 10. So 10 plus 1 is 11. So where this 11 will be stored? Resultant matrix 0, 0. So resultant matrix 0 0, here 11 will be stored. Here 11 will be stored. So let us try few more iterations here. Next 0 0 is completed. Next 0 1. So here it will be 0 1, here it will be 0 1, I j 0 1 0 1. So what it does? So from matrix A 0 1, what is 0 1? 2. From matrix B, what is 0 1? 20. So it will be 20. 20 plus 2 is 22. So where this 22 will be stored? Resultant matrix of 0 1. So resultant matrix of 0 1 is here. So here 22 will be stored. 22 will be stored. Similarly, 3 plus 30, 33 will be stored here. Next 4 plus 40, 44 will be stored here. 5 plus 50, 55 will be stored here. 60 plus 6, 66 will be stored here. 70 plus 7, 77 will be stored here. 80 plus 8, 88 will be stored here. 90 plus 9, 99 will be stored here. So this operation will be performed by these set of lines. So now what we have done, we have read matrix A from the keyboard, we have read matrix B from the keyboard. Next we have performed matrix addition also. So after that, result is stored in resultant matrix. Next what we need to do, we need to display the output. Okay, output on the monitor. Okay, so here what I am doing next here, okay, I want to display the elements of first matrix. So this code again, it works like this. So this is the matrix A. Here if you look at this part of the code which is used to display first matrix. So here the value of I and j will move like this, same I and j. So 0 0, 0 1, 0 2, 1 0, 1 1, 1 2, next 2 0, 2 1, 2 2. In this fashion, the values of I and j's will be generated because of this. If you trace it, you'll get to know. So now first time what happens, I'll display first time matrix 0 0. So what is matrix 0? Matrix A of 0 0. So value 1 will be displayed. Okay, after displaying that, what I am doing, I am leaving a space here. That is why after displaying 1, we have a space here. Okay, so once I complete displaying first row, that is 1 2 and 3, what happens? I'll come out of this internal for loop. After displaying first row, I'll come out of the internal for loop. So to this point I'll come. When I come to this point, there is a \n statement. It means the next output which it produces, it should be produced in the next line. So after executing this statement, where the control will go, I++, it means it will go to this point. So at this point what we have, 1 0, 1 1, 1 2. It means now we will display the elements of the second row. 4 5 and 6 will be displayed because of the values of I and j. So after displaying the elements of second row, what happens? Next we want to display the elements of the third row. So now the value of I will become incremented, it will become 2. Okay, so again these are the pairs of values that will be generated, 2 0, 2 1, 2 2. So now what happens? 2 0 means 7, 2 1 means 8, 2 2 means 9. So 7 8 9 will be displayed. So what this part of the code do? This part of the code, it displayed the elements of matrix A. Similarly, this part of the code, what it will do? As we displayed the elements of matrix A, similarly this part of the code will display the elements of matrix B like this. So 10, 20, 30 is, so whatever the content of matrix B is there, right? So 10, 20, 30, 40, 50, 60, 70, 80, 90. With the help of this code, we were able to display it. So try to trace this code, so you will get to know how exactly it displays, as we traced it for matrix A. Next, similarly, this part of the code, what it does? it displays the elements of resultant matrix. So this is our resultant matrix: 11, 22, 33, 45, 55, 66, 77, 88, 99. So the elements of the matrix were displayed here with the help of this part of the code. Okay. So in this program, what we discussed about reading of two matrices. Next, performing addition operation on them. After that, displaying all the three matrices. Okay, displaying all the matrices. So similarly, in the subsequent videos, we'll be discussing about all the other important C programs. For all our further updates, subscribe to our channel and hit on the bell icon. Thank you.